E-Maths class, Fatima Convent High School. Myself, Dipali. Introduction to Trigonometric Ratios, Chapter 8, Class 10. In this session, we are going to understand about trigonometric ratios and complementary angles. Now, we are very much familiar with the word complementary. We know that sum of two angles, if it adds up to 90 degrees, then we call them as complementary angles. So, when you talk about complementary angles, then if you recall that two angles are said to be complementary if their sum is equal to 90. In triangle ABC, right angled at B, you can see that these two angles are complementary to each other, A and C. We know that angle A plus angle C is equal to 90 degrees and they form complementary angles. Now if you see, then if I take angle A as theta, then angle C is 90 minus theta. Or I can say angle C is equal to 90 minus A. Using this and finding the trigonometric ratios for both the angles. For angle A, this is opposite side and this is adjacent side. And for angle C, this is opposite side and this is adjacent side. So, if you try to find the trigonometric ratios for sine A, then it is BC upon AC, cos A is AB upon AC, tan A is BC upon AB, cosec A is AC upon BC, sec A is AC upon AB, cot A is AB upon BC. Now let us write the trigonometric ratios of C. It will be 90 minus angle A. For convenience, we will be using it as 90 minus A instead of 90 minus angle A. So if you see the trigonometric ratios of 90 minus A, that is angle C, you get sine 90 minus A is AB upon AC, cos 90 minus A is BC upon AC, tan 90 minus A is AB upon BC. Cosec 90 minus A is AC upon AB, sec 90 minus A is AC upon BC, cot 90 minus A is equal to BC upon AB. If we compare these two ratios, you will find that sine 90 minus A is AB upon AC is equal to cos A, cos 90 minus A is BC upon AC is sine A. Similarly, tan 90 minus A is AB upon BC is cot A, cot 90 minus A is BC upon AB, which is tan A. Sec 90 minus A is AB upon BC is cosec A, and cosec 90 minus A is AC upon AB is sec A. So, you can say that sine 90 minus A is cos A, cos 90 minus A is sine A, tan 90 minus A is cot A, cot 90 minus A is tan A, sec 90 minus A is cosec A, and cosec 90 minus A is sec A. These are the important relations which we need to learn. This is true for any ratios which lie between 0 and 90 degrees, where A is 0 or A is 90. Note that tan 0 is 0 and cot 90 is also 0. Sec 0 is 1 and cosec 90 is also 1. Same way sec 90, cosec 0, tan 90 and cot 90 are not defined. They are complementary to each other. Let us solve some examples. Evaluate tan 65 upon cot 25. Taking any one as the reference, we say tan A is cot 90 minus A. Now here our theta is A or 25. We replace the value, then we get tan 90 minus 25, which is tan 65. So I can write tan 65 upon tan 65 in place of cot 25, which is equal to 1. Similarly, Sine 3a is equal to cos a minus 25, where 3a is an acute angle. Find the value of a. We are given that sine 3a is cos 9a minus 26. Now sine 3a is equal to cos 90 minus 3a. We write this from 1 that cot 90 minus 3a is cos a minus 26. So 90 minus 3a and a minus 26 are both acute angles. Therefore, you can write 90 degrees minus 3a is a minus 26. Therefore, a is equal to 29. Likewise, cot 85 plus cos 75 in terms of trigonometric ratios of angle 0 and 45, then we get cot 85 plus cos 75 is equal to cot 90 minus 5 plus cos 90 minus 15. Then we get tan 5 plus sine 5, which is our required expression which is asked in the question. Now, so aren't they very simple? Now let us solve the exercise. Exercise 8.3. Exercise 8.3. In the first question, we have sine 18 degrees upon cos 72 degrees. We are supposed to solve. Then we know I can write sine 90 degrees minus 72 degrees upon cos 72 degrees is equal to cos 72 degrees upon cos 72 degrees is equal to 1. Second one, tan 26 degrees upon tan upon cot 64 degrees. Then I can write tan 90 degrees minus 64 upon cot 64 degrees is equal to cot 64 degrees upon cot 64 degrees, which is equal to 1. Then third one, cos 48 degrees minus sine 42 degrees is equal to cos 90 degrees minus 42 degrees minus sine 42 degrees, which is equal to sine 42 minus sine 42 degrees is equal to 0. Isn't that easy? Now fourth one, cosec 31 minus sec 59. Then we have cosec 31 minus sec 90 minus 31. So cosec 31 minus cosec 31, which is equal to 0. Now we have question number 2. We are supposed to prove there in the first one that tan 48 degrees, tan 23 degrees, tan 42 degrees and tan 67 degrees is equal to 1. Here we know tan 48 degrees and tan 23 degrees we keep as it is. In place of tan 42 we are taking tan 90 minus 42 because 42 and 48 are complementary. Same way we take tan 90 minus 67 degrees or 23 degrees. So we get 1048 degrees, 1023 degrees, cot 48 degrees and cot 23 degrees. So we get 1048 degrees, 1023 degrees into 1 upon 1048 degrees into 1 upon 1023 degrees. We can eliminate this and get the answer 1, which is equal to RHS, hence proved. Number 2 is similar, where you have to do cos 38 degrees, cos 52 degrees minus sine 38 degrees minus into sine 52 degrees. Will you be able to solve this for homework? We go ahead with question number 3. Here we have tan 2a is equal to cot a minus 18, where 2a is acute angle. We have to find value of a. So here tan 2a is equal to cot 90 minus 18 cot 2a is tan 2a is equal to cot a minus 18. This is given to us. Now in place of 10 I can write cot 90 minus 2a is equal to cot a minus 18. Now can I compare both of them? Yes. So 90 minus 2a is equal to a minus 18. So 2a plus a is equal to 90 plus 18. So 3a is equal to 108. A is equal to 108 upon 3 is equal to 36 degrees. Let us do the fourth one, which is similar to it. Tan a is equal to cot a. We have to prove a plus b is equal to 90. So we have tan a is equal to cot b. Now tan a is equal to 10 90 minus a minus b, because 10 90 minus theta is equal to cot theta. So I get a is equal to 90 minus b. So a plus b is equal to 90. Let us do the fifth question. Here sec 4a is equal to cosec a minus 20. 4a is less than 90 degrees and find value of a. It is similar to the one we did. So that would be your homework. Now question number 6. Question number 6. In question number 6, we are supposed to prove that it is given that A, B and C are interior angles of triangle ABC. We have to show that sine b plus c upon 2 is equal to cos a upon 2. Now here We know according to angle sum property A plus B plus C is 180 degrees. So B plus C is equal to 180 degrees minus A. If I divide that equation by 2 on both the sides, then I get 180 upon minus A by 2 and B plus C by 2. If I solve this further, I get B plus C by 2 is equal to 90 minus A upon 2. Now sine B plus C upon 2 is equal to sine 90 minus A by 2. So I get sine B plus C by 2 is equal to cos A by 2. Hence it is proved. Question number 7. In question number 7, it's very simple. We have to express sine 61 plus cos 75 degrees in terms of trigonometric ratios between angle 0 and 45 degrees. So now here sine 67 plus cos 75 is equal to sine 90 minus 23 degrees plus cos 90 minus 15 degrees, which is equal to cos 23 plus sine 15. I got my theta between 45 and 0. We simply just converted this into its complementary angles by 75, 90 minus 15, 90 minus 75 gives 15, and same way I get 90 minus 23 and cos 90 minus 15 gives me the required ratio, which are complementary to each other. Thank you.